So hash functions. The most important thing about hash functions is that they are a property of the data. Okay? They're a property of the data. The data structure, the hash, doesn't know anything about the hash function. In this case, we've got CSSC IDs, and we're going to remove the CSSC part. That only makes sense if you've got CSSC IDs that you're putting into your hash. So it's a property of the data. We want them to be fast to compute. So what that means is, if I'm going to put 1 million elements into a data structure, I don't want to wait for 1 second to get an integer back, and this has to return an int. We'll come back to why. But I don't want to wait a second to get an integer back from the hash function if I've got 1 million things to do, right? It's never going to finish. So I want this to take just a few cycles to compute whatever this is, based on whatever I give it. If I give it CSSC IDs, what I've shown you there is really only 4 operations, so that's going to compute very quickly. Yeah? If 2 elements, let's say things, are equal, and I'm going to put equals in quotes because I'm going to leave it up to you to determine what equals means. But if 2 things are equal, they should return the same value. And equal, of course, can mean all different things. If we're thinking about objects, the equals is based on the location on the heap. If we're thinking about strings, it's a character-for-character comparison. If we're thinking about students, it's probably some combination of red ID or name and address or email or something like that. It should always return the same value. And there's 2 interpretations to this. The strict definition is during an instantiation. Like during one, that's not how you say it. Let's say it like this. During one run of the code. Okay? So if I start a program and I call this hash function with an object, that's key. If I call this function with an object, every time I run it and I call with the same object, I should get the same number back. So if I put your grades into my associative arrays, and then I come back and say, whereabouts is your grade, I've got to get the same answer back based on your ID. I don't like this one. I don't necessarily agree with this one. But I'll explain where it comes from. It's possible to return different values for an object in separate runs. So if I run my code today, and I try and get a hash code associated with a value, and then I run it tomorrow, and then I run it next week, each of those could give me different values. The reason I don't like it, the reason that I try and avoid it, is because very often we want to do things like serialization, where we run some code, we create something, create a data structure, and then we're going to store that to disk. And if you store it to disk, you can't do this. You have to make sure that every time you call the hash code function, it gives you the same answer back. and it doesn't matter when it runs. But the reason that this is true harks back to some of our earlier lessons. So remember, we were talking about objects. And the object class has a few methods that we need to overwrite. Do you remember what those methods are? So toString. So if you want to try and print something out, you need to overwrite the toString method, otherwise you'll just get the memory location. Equals. The way the object compares whether two things are equal is based on its memory location. Hash code. Hash code. Excellent. Hash code, right? Because the object class has a hash code, but you overwrite it when you create your data. And the hash code that the object class uses is based on its memory location, and that's why this statement is important. If you don't overwrite the object's hash code, every time you run it, your object gets put in a different place in memory, and you get a different answer back. Okay? The last thing that we want our code to do is to minimize collisions.